Now, I want to go one step further, and I want to talk about situations where I am faced with a sentence where I know that something has increased or decreased, and then I'm trying to figure out a piece of information that wasn't provided based on this increase or decrease. So before we do that, I'm going to talk about the multiplier process. Multiplier process is something that I came up with to try to help students do these types of problems. And it's pretty straightforward. It's a two-step process. It starts with something like percent increase, percent decrease, and then you go from there. That kind of determines your process for you. So I've got an example here of a 10% increase and how you want to think about making this multiplier. This multiplier is useful in this section, and then it's useful throughout the rest of this unit, especially as we get into talking about financial situations where you have interest. You can use the multiplier concept as a way of thinking about what is the exponential base in your formulas. Okay, so a 10% increase means you're adding 10%. So mathematically speaking, that means you take 100%, you add 10%. That's easy to add up. That's 110%. And then from there, the second step is just turning that into the decimal representation. So just real quickly, if you have confusions about the decimal representation and the percent representation, this is the decimal representation, this is the percent. Right? There's another representation, which is the fraction, but for our purposes in math, decimals are typically easier to work with. So there's times when you're going to need to go from the percent to the decimal, and there's times when you're going to need to go from the decimal to the percent. And what you want to be able to do is associate a way of going in each direction. Now, I'm going to tell you what to do, but for a lot of people, they get confused and they forget. In the heat of the moment and the pressure of the exam, they're like, oh my God, do I multiply or divide? I don't know what's happening. So this to me is a little scaffolding device that helps you organize your thinking, because most people, if I say, what's 50% as a decimal, they would be able to say 0.5. Like they know that's a half, they know a half is 0.5, so it's not like something that they have to remember, it's something that they're familiar with. So how do I go from the percent representation to the decimal representation? I just divide by 100. And how do I go from the decimal representation to the percent representation? I just multiply by 100. Okay. So my idea of the scaffolding is, like a lot of things in math, they come down to, especially if you're in a math class, but also if you're in the real world and you're trying to like do some math and you forgot how to do something, they come back to, like, I think, things that you remember, things that you know, and then using that to help, if you're confident about your own mathematical abilities, to be able to like build forward and say, okay, well, if 50% is 0.5 and I want to change from a percent to a decimal, dividing by 100 makes sense, because 50 divided by 100 gives me 0.5. Or in the other situation, if I want to take my decimal and turn it into a percent and I don't remember whether I'm supposed to multiply or divide, I know 0.5 is 50%. And if I take 0.5 and multiply by 100, that's 50%. So that's the right thing to do. Okay, but you're welcome to write this down and use that structure to help you kind of organize your thinking. So the second step of the multiplier process is to change from a percent to a decimal. You can move the decimal 2 places, or you can divide by 100. The end result is that the multiplier for a 10% increase is 1.1. Okay, so we're going to do a couple more of these problems because I just want to drill this part. Because if you can do this part, you're like halfway through the process. So what would a multiplier for a 30% increase be? Go ahead and take some time to work it out. I want to know what the multiplier for a 30% increase would be. Okay, you got an answer? Multiplier for 30% increase. For the multiplier for 30% increase. Okay. let's maybe step back to the very first part of it. How do I start? 30% increase.
100% plus 30.
So I'll do 100% plus 30%. That's 130%. And then what do I do after that?
Then you divide by 100.
Right? So 130 divided by 100 is 1.3. So 1.3 is the multiplier for 30% increase. Okay, let's try another one. What about a 5% increase?
That becomes 105%, and then you divide by 100 and you get 1.05.
Good. So 5% increase of 1.05 is the multiplier. All right. Try a 12% increase.
So I had a question. So every time we're using a percent sign, we're always using 100 because the percent is always 100.
Base is 100%. So we're adding on percentages or taking away percentages starting from 100%. And then in the end, we take the percent sign off so we can use it in a mathematical operation. Okay, so what's a 12% increase? The multiplier for a 12% increase.
That's 1.12.
Okay, good. Okay, for this last increase, it'd be good if you could text me your answer because I've heard from Erica. I feel good about the fact that she can do it, but why don't you send me a text with your answer? So I got a couple of 1.089s. That was good. So let's switch over to a decrease now. How do things change if we think about decreasing? So if you look at this process, there's a place where we could change it to reflect that we're going down instead of going up. What would you change in the process to reflect that it's a decrease now, not an increase?
The first step, the 100% plus 10, you subtract it.
Exactamundo. So we start with 100%, we subtract 20%, that gives us 80%, and then we change that to a decimal, which is 0.8 by dividing by 100, okay? So that's a 20% decrease. That's the multiplier for a 20% decrease. Okay, I'll leave that up. Here's another one for you to think about. What's a 35% decrease? Because we're starting from 100% and we're going down 35%. We still have a positive number. I got a couple answers here. Let's go through the process again. 100% minus 35%, that's 65%. Turn that into a decimal, that's the multiplier. 0.65 is the multiplier for a 35% decrease. Okay, we want to finish with the decimal version of it because we're going to use it mathematically. All right, try these next two. You can send me a text. I'll give you a couple minutes to work those out. Again, a couple of people I haven't heard from, so I'm not sure where they are at all on this. If you want feedback, just send me a text, send me a chat. Okay, seeing some good answers. Okay, so what I'm going to do is I'm going to shift over to the instructions about the full process here. So in the percent change problems, where you're going to see something like in 2018, there was, 36,000 people that liked eating hot dogs. And then there was a 8% increase. How many people were there in 2019? Something like that. So first step is just to look at the language and determine if you're working with an increase or a decrease. Now, a lot of times that'll be obvious because they'll say increase or decrease. Sometimes it'll be more like more or less or further or shorter or something like that. Sometimes a little more disguised, and you have to bring in some contextual knowledge, like you're talking about taxes, right? Taxes can actually go both ways. Like if you're talking about a sales tax, that's an increase. If you're talking about withholding from your paycheck, that's a decrease. So you got to look at the words, look at the percent, focus on the percentage number, and look around it to see what the clue word is that tells you whether it's going up or down. Then you figure out the multiplier. That's what we just practiced. So you're halfway through the problem when you get to step 2. Now, step 3 and 4 basically boil down to you're going to either multiply or divide to finish the problem. I say apply the multiplier because it's called a multiplier. You should sort of logically think about the fact that you're going to try to multiply this. But sometimes that's the right thing to do, and sometimes dividing is the right thing to do. And we're going to talk about why and how you can tell. So let's take a look at a sample problem. Okay, so just going back to our data from the beginning, some people argue that if there were better training and de-escalation, then you would have fewer people being shot by the police. So if a government study indicates you could get 10% fewer police shootings, and there were 1,001 shootings in 2019, how many would we expect to see in 2020, given the better training? So the first step of the process is just to look at the percent and figure out, are we talking about an increase or decrease?
Decrease.
Yeah, because fewer shootings means we're going to have a decrease. So then your job is to take the 10% decrease and make the multiplier. So that's the process we were just practicing. So you come up with your multiplier. What's the multiplier? You can go ahead and say it out loud.
0.9.
Good. Okay. And then at this point, I would multiply the multiplier, because that's the whole point. That's why it's called a multiplier. And this is my answer. Now, of course, the context tells me 0.9 doesn't make sense. So I'm going to answer 901 police shootings in 2020. Okay. So that's an example of where you go through the process, figure out the multiplier, you apply it, boom, you got your answer. Now let's look at a situation where that doesn't work. And we got to go on to the next step. So you got a 4.5% increase in bus rides. Okay, what's the multiplier for a 4.5% increase?
I got 0.955. Should I be rounding here or no?
Not rounding, but also you went down. It's a 4.5% increase.
Okay.
I'm going to focus on the words around the percentage word.
Okay, yeah, I see where I was supposed to add the 4.5.
Right, so the multiplier
is 1.0445.
Good. Okay, now if we apply the multiplier, we're going to do 3, 4, 5, 6, 7 times 1.045. But when we do that, get this number, and of course we would round 3, 6, 1, 2, 3. We think about this, I think you'll agree this answer doesn't make sense. Does this represent an increase from 2018 to 2019?
No.
Right. This would represent a decrease. Now, most people kind of instinctively want to go back and change the multiplier. Don't do that. The multiplier is the multiplier. The multiplier is set based on the language in the problem. Okay? It was a 4.5% increase. The problem is we don't know what it was a 4.5% increase from. So we can't multiply. We need to divide. That's going to take us around the back way to figure out the answer. So if we divide by 1.045, we get an answer that makes sense. And of course, I'm going to round. So this answer should make more sense. And if we actually apply the multiplier to the 33,078, That's how we get 34,567. So the problem sometimes is that the multiplier needs to be applied to a number that we don't know. That creates kind of an algebraic situation. We don't need to see it algebraically, but let me just show it to you anyways. Basically, we have this situation, a 4.5% increase, which is the 1.045 multiplier. So that times however many people there were taking bus rides in 2018 gives us 34,567. So how do we solve that problem? Well, algebraically, we undo the multiplication by dividing. So that's why we end up dividing here. Okay, let's look at one more. I'm going to be quiet here for a minute, let you kind of think through the whole problem. You're welcome to send me a text along the way. You want to check in, or send me a text at the end with your answer. I can give you some feedback. Okay, let's talk about it together. So first step, you got to make the multiplier. That's actually two steps in one. But before we make the multiplier, we got to decide, are we going up or are we going down? And again, you want to focus on the percent number, not thinking about whether you want the answer to be bigger or smaller, but whether this percent situation is an increase or a decrease. So what did you say about a sales tax? Is that a 10% increase or is it a 10% decrease?
That's an increase.
Yeah, it's a 10% increase. Because when we go to the register and we buy something, the price goes up, right? We have to pay more money because of the sales tax. So that's a 10% increase. A 10% increase makes what multiplier? Now we're on to the multiplier process.
It's a 10% plus 100%.
Yep.
We got 1.1.
1.1, correct. Okay, so now we're halfway done with the problem. Now we got to figure out, taking $110, are we going to multiply by 1.1 or are we going to divide by 1.1? So this is another way to kind of think about it. Instead of multiplying and then asking yourself if it's right, you could just kind of think about both or do both and then see which one makes more sense. So in this one, the price goes up. But I hope that you're saying to yourself, wait a minute, oops, that doesn't make sense. I shouldn't be paying more money. Sorry. The price before I went to the register is not more. Right, Thomas. So we would want to actually divide. This is the answer that gives us a sensible result. $100 is the result of the calculation that makes sense for the problem. The item before sales tax was $100. When we went and paid 10% tax, we paid $110 altogether. Sometimes people want to just take 10% of whatever and then add it or subtract it. Half of the time that works and half of the time it doesn't. That's why that's not really a reliable process. That's why I'm giving you this other process, this multiplier process where you build the multiplier and then you either multiply or divide. Now, just a quick point, you could also do this as a proportion if you really like sticking with proportions, and there's videos in the book that kind of guide you to that. The problem then boils down to not are you multiplying or dividing, but do you put the number on the top or the bottom? And so again, you can kind of treat it as a either or situation and then figure out which answer makes more sense. You put it on the top, you get one thing. You put it on the bottom, you get another thing. Which answer makes sense for the context? Sometimes people see questions that have percentages in them and they freak out. So I don't know what the real numbers are, but I know that it is true that in general, people's support for the concept of gay marriage has generally increased over the years. And now it's past a majority of Americans who are supportive of gay marriage. This question has two percentages in it, but one of the percentages is measuring something. It's like $87 or 96 people or 132 cars. The percent is just a unit. The other percentage is talking about how it changed. That's where you need to focus. So this is kind of tricky from that standpoint. You can't just look and say, oh, there's the percentage, that's the one I'm going to use. You're going to end up using both of those numbers, but one of them is about the change. So that's the one that has to do with the multiplier. And then the other one is the one that you're just going to treat like 60 and figure out whether you increase or decrease or multiply or divide or whatever and come up with your answer. The only hint I'll give you is the answer is not 45%. It's not as simple as just subtracting 15% from 60%. And that's what the word relative is supposed to indicate here, is that relative to where it was in 2015, it went up 15%. And that's different than saying it went up 15 percentage points. So same process. Get the multiplier. Apply the multiplier. Could be multiplication, could be division. Okay. So first of all, we start with the 15%. Are we talking about an increase or a decrease?
An increase.
Good, because it says 15% increase. So from there we get our multiplier.
$1.5. I mean 1.15.
Good. And then we're either multiplying or dividing, right? So it's either 60 times 1.15 or it's 60 divided by 1.15. One of those answers is going to make sense as my result. Notice that I'm starting with 60. Starting with 60 because that's the number that I'm basing this off of. And in the division, multiplication doesn't matter who goes first, but in division it does. So if I started with 1.15 and then I divided by 60, I would get the wrong answer. Which one of those makes sense to you?
Okay, so what makes sense to me is the 60 divided by the 1.15.
Okay, 60 divided by 1.15. And I agree with you because that gives us a smaller number, and a smaller number makes sense because we were talking about 2015 to 2020. We saw an increase in support, so this number should be smaller, 52.2%, something like that.
Mm-hmm. Yeah.
Again, there's no instructions about rounding, so you could have said 52%, you could have said 52.2%, you could even say 52.17% if you want, right? But don't carry around all of those details just because you feel like you have to be exactly right. Better to be able to communicate what you're talking about. So if we needed to make a sentence here, we would say something like the percentage of people who supported gay marriage in 2015 was only 52.2%.